All right. Thank you very much, Tiffany. I'm super happy to be here in front of this very relevant audience. And I have recently started a group in February, which so far consists of me and hasn't done anything really. And I therefore want to use this kind of uh, exposition to this audience to also tell you a bit about my process now. Obviously, I'm thinking a lot of how to position myself in this very agile and fast environment, and I couldn't have asked for a better contextualization for my talk with the two keynotes that we heard today, at least if you were in this session, also for the second keynote by Chris, but also what James Zoe has said this morning. And by education, I am a pharmacist, and I did a PhD in pharmacology, which is a very causally driven domain. And so I also have this kind of in me, and I'm sure you're familiar with this statement that seems superficially trivial, but I'm sure that everybody's also familiar with that it's not that trivial if you, for example, then try to determine the impact of nature versus nurture on any given trait or disease, and you very quickly hit the curse of dimensionality. And this is often complicated by the fact that our modern experiments then look more like this, where you have a multitude of factors and views. And it's quite natural to look to AI to help us cut through these complexities, particularly the ones that humans are not very apt at tackling, in the same way that a nice diffusion model helped me create this nice illustration. And if you forced me to do the slides without the help of a diffusion model or an AI agent, then it would be much less impressive. But going beyond the artwork is, not surprisingly to anybody in this room, more demanding. Here on the left, we see a human-made, purpose-driven illustration of what happens when EGF binds to a cell. So you see the result, you see the cascade, you see what you might do to intervene with this process. And GPT-4 knows all of this, better than humans probably, but it cannot instruct DALL-E to create the same purpose-driven illustration. It's not a surprise that this is just a beautiful mess. And while machine learning researcher can tell you exactly why this happens, it's not obvious how we would go then from the right to the left in making them actually do what we want them to do. Why do we care? Because productivity matters, and we think of science as this high-level reasoning discipline, and we spend our time deploying all of this, maybe through decades accumulated knowledge that we have. But that's not all about science. We also have these other tasks, the more menial and tedious sort. And depending on who you ask, particularly the people that do the actual work, this might be the majority of the time that you spend. So I think this is a much more viable target for the agentic systems, at least at first, than trying to get them to do everything. So one of the main questions that I ask myself is, how do we use these new technologies to improve efficiency in science in the way that we want without harming the epistemic process? Because that's another feeling that you get, for example, by listening to the keynote by James this morning. Who holds the steering wheel in this? So I try to determine my principles around this and then guide my research by these principles, asking the scientists what they do. And if you are in any way related to software engineering as a discipline, you know that the user typically doesn't even know what they want until you show them what they want. And I think I don't need to explain, because James did that beautifully, that we can then develop and deploy AIs to do whatever we want. And I want to replace the menial and tedious. So this is what I'm trying to do. But what I also realized in my postdoc is that it's often useful to have a middle layer. So developing developer toolkits, give them to somebody who knows about programming, but also knows the audience or sits close to the audience, is able to go to the audience, talk to them, sit down with them, look at their workflows, and figure out how we would apply the software to their use case. And I have the feeling that I want to build a context-driven, a user-centric framework around these things. We have started with some of them, and we are pushing into more directions. And I think it is pretty clear, also listening to other talks, that context is really A, super important, and B, not something that AI agents can do very well at the moment. So we started with this knowledge representation framework that was already about context. It was about finding your way through a big ontology by just specifying a couple of concepts that are really important for your project and then going with that. So it's kind of a hybrid. And then since we had this compact context, it was really useful when the LLMs arrived and we could explain to the LLMs how they would use this knowledge graph. So that was my experience from that. And these two are published. And now I want to use the context for other parts of the knowledge management and project management workflow in science. For example, extraction is super noisy. And if you've tried your hand at it, you know that it's super subtle and you can go wrong in many ways. And similarly, we now have all these tools. So we recently, with collaborators from Denmark, started an MCP registry, which is kind of the crowdsourced alternative to the big monolithic models that we have seen some people present. Then you need to encapsulate this, so you don't want the agents to wreak havoc on your host system, so you kind of want to constrain it. And then you also want to figure out, how do I validate this even? Because this is a very complex kind of setting that we are getting into with these autonomous machines. And this is what I want to talk about then later in a bit more detail. And what I think is very important is to then have a holistic perspective on this and take the user through it. So we started with this Biotope software, which basically is at the moment like a cookie cutter that takes you through all of these aspects and asks you, for your project, what do you need? So I won't bore you with this. This is, as you can see in the numbers in the bottom, we pre-printed in 2023, and the journal article came out this year. So in terms of agentic system, this is an eternity. And obviously, this is nothing new to most of the people here. So you can do prompt engineering. You can do retrieval augmented generation with structured or with unstructured data. You can call other softwares. You have the agents call them. It was tool binding, and now it's MCP. You can chain them together and then make them reason with one another. You can try to look at other modalities like images. And so far, so good. Now what we want to get into is agentic systems. So it's important to define, because there's a lot of fluidity at the moment, what this even is. And for me, it means at the moment that there are autonomous systems that typically leverage LLMs, because that is the technology that we have. And they plan and reason and execute tasks without the need for continuous human intervention. And the level of intervention probably needs to follow the complexity of the task and maybe your requirements, as we may also have gotten from the previous talk. And there are a bunch of technologies out there. And for me, it's quite obvious that they seem to follow an inverse correlation between the transparency of the approach and the scalability. So something like a simulated Stanford with multiple parallel meetings of several experts. You may have got the feeling from James's response to the question this morning that reading through all these protocols, it's A, not very easy, and B, does it even help you? Because it's maybe more complex than trying to solve the problem yourself. And then you have the other side, which is something like constraint generation or React, which Chris mentioned earlier today. And these are sequential and they can be very structured, but they need to be executed sequentially, so you can't scale them very well. And when we ask ourselves, how do we now deal with this? For me, this often doesn't come down to technology, but rather to trust. So if you've been to San Francisco, you may have seen these Waymo cars driving around, the driverless vehicles. And I think the reason that they're not in other parts of the US broadly, or even in Europe, is not one of the technology. It's one of responsibility. It's one of regulatory concerns. It's one of trust, ultimately. And we see the same thing in the things that we do with the software agentic system. Cursor, if you know it, it's an IDE that is very AI first, and you can use it to vibe code or to just help you. And they are famously the company with the quickest $100 million of annual recurring revenue magical barrier hit in about a year, and they hit 200 million in about 2 years. And that is much faster than even other comparable companies at that scale. And what is most impressive and maybe a bit frightening is that they do it with a fraction of the people that you used to require to run software that has global reach and so many customers, like 25 people. And the reason that they can do this is because they outsource the creative work or the product as it does to these GPU-driven agentic systems. And the clever thing that they do is that they deploy it to a very expert customer. So you are the programmer, you're in the loop, and you are responsible for determining whether the code that it wrote is any good, and you want to deploy it to your production setting. But how would we make sure in a more complicated, maybe in a health critical context, as the last speaker emphasized. And for this, I want to explain now a little bit about this Karenina framework, which is named after a principle that is named after the beginning of the book, which you're probably familiar with. But the principle is more a philosophical one, which is there is one way to succeed and many ways to fail. And I'm not even sure that is correct in this instance, but it was kind of poetic enough to take it as a name. So let me try to explain. There was this famous paper by Sir Francis Galton in 1907. He famously didn't really believe in democracy, so he thought the best way to check whether democracy works is to go to a fair and ask people if they can guess how heavy an ox is, which in this case was about 1,200 pounds. And while the individual guesses of the people were quite far away from the mark, he was shocked back then that the mean of these guesses was quite close. But then what's shocking to me is that he believed that this is evidence that democracy works, because how are you representing democracy as a scalar, right? You can't make a loss function that tells you how good a democratic system works by predicting one number. We have multiple stakeholders, we have many dimensions of being right or wrong. I think this was also something that we heard in the last talk pretty impressively. So benchmarking now is basically you ask any question, you have an agentic system that goes off and even does a little university simulation, and then you get any answer. So how do you validate? You give it to a domain expert and you tell them, tell me how good this is. And then they say, maybe, yeah, this is about a 7 of 10, but what does that mean? And this is then probably only the first thing that you think of, like, is this useful as an answer for the question, which might not be similar between you and me, what we think the usefulness is. So we also have categories, and we did this a bit in clinical research. So intervention recommendation, we made 5 categories. These are 3 of them. And they kind of contradict each other also, because if you have a very comprehensive answer, it might not be very useful because the user doesn't understand what it means or doesn't want to read a textbook. And what do we do in this real world? Like we care about these in the real world. So what do we do if we want to know if these hold? Again, more human time. Read this, tell me if it works. And this is obviously super expensive, and we can't really scale this in any way. So Karenina tries to get around this by shifting it a bit earlier in the process. We have this project with open targets where we collected some business questions. You see 2 of them here. And these are the human curators that create these business questions. And they are multifactorial and they have these dimensions. So what we want to do is we take these question and answer pairs. And Karenina is a software that helps people parameterize in an LLM assisted way, but also with a graphical user interface. And this is also very close to the previous talk. This into an LLM readable and executable protocol for each question or the entire benchmark. And then you can take these are pydantic classes, right? So you can bind them to LLMs, you can bind them to a arbitrary battery of LLM judges, and then you can evaluate lots of ablations that you want to run, or you can even run future models without having to go back and read anything of the answers that they give you. So basically use the domain expertise where it can be most efficient. Since I'm now in this like fluid state and trying to figure out what I can do in this system as a recent group leader, and I don't really also know what you might be finding interesting in terms of the conclusions, I will abstain from a conclusion and I will give you a bunch of unordered aphorisms that I kind of came up with when I tried to think of a conclusion for it. So the system is working against us. This is something that I guess everybody has learned in the various work. So we need to hack it. We need to make sure that we can collaborate open source while still giving everybody contribution, credit, their PhDs, whatever they want, right? We need to iterate fast. This echoes what John Jumper said. We need bounce ideas. And in science, this means you need to be as open as you can. And this is difficult. Context is key. Communication is key. Accessibility is also key. And what I see, like on a more technical level, is that it might be useful if we have these things that many people might be working on to maybe come together and agree on protocols, and then you implement your solutions, but you still have at least the interoperability of the FAIR principles. Being over-enthusiastic about development, also as mentioned by my previous speaker, is very useful. And also something like the talk by James, you get inspired by this. But it's also then useful to step back, look at the thing and see what can we abstract from this? How do we proceed? Software is a communication tool. Think about your users, not just your peers or the people that will review your paper. Build something that you would also be motivated to maintain. When to use an agent, for me, is the most important question of all these questions about agents. And it would be a missed chance if I didn't also put in a quote by one of the most recognizable faces of Liverpool. And forgive me for being a little bit cheesy, but you may say that I'm a dreamer, but I'm pretty sure I'm not the only one, particularly in this room. I need to thank everybody that made this possible, obviously. So sorry for not doing that before you clap. And if you want to contribute, help, be test user, rant at me about anything, just please hit me up or write me an email or anything. Thank you.
Thank you so much. And to keep us on time, unfortunately, we have time for just one question for this talk, if anyone has one.
So I'm going to go back to the beginning of your talk where you sort of invoked, at least in my mind, Joanne Macy-Juska's famous line about, I want AI to do my dishes and laundry so that I can write poetry and make art. So in the pharmacology context, that's things like, okay, what's going to be a reasonable in vitro model that I can take my hit into and try to do some optimization that won't cost too much, but that regulators like, where's the right animal model for this particular phenotype, that kind of stuff that requires kind of detailed contextual knowledge, but is really that kind of, it's not quite the bureaucratic stuff you were talking about, but it's in the neighborhood. So specifically focused on pharmacology, where do you think the places for wins are to help pharmacologists in drug discovery? And I hope your answer isn't going to be, we just put it all into the LLM and it'll give us a hit. I want to hear about how you're going to do the dishes and the laundry.
So this is an excellent question, not just because it is a good one, but also because I can answer it perfectly. So Open Targets have sponsored a project with 4 postdocs that started late last year. And for 3 years, we will be trying to modernize the Open Targets platform with what I just described. And Karenina, Francesco, the postdoc who leads Karenina, works on this Open Targets project. So we have all the knowledge in Open Targets. And now the question is, how do we, we are at the same time the software developer and this like middle layer, because we worry about the customer as well. And in the next couple of months and maybe 2 years, we will see, because we obviously need to evaluate everything that we're doing there, and it's all changing very fast. So stay tuned, I would say.
Thank you so much.
Thank you.